And I would say, going to grad school, what you really want to focus on is what kind of research are you passionate about, and then find what faculty are doing that kind of research. And then
Right.
the major is not that important. Like in the same lab, you could have graduate students um, that are pursuing a degree in chemical engineering or biomedical engineering or biochemistry or chemistry, but they might be
Right.
doing very similar research, right? And that's kind of the focus of your PhD. That research is the important thing that is going to open the doors as you move forward.
Dr. Betancourt, thank you so much for joining us today. I want to kind of preface our conversation with the fact that we started this about a year ago, the Chemistry Student Podcast, with the kind of intentions of talking to students and faculty and highlighting the experiences and opportunities of these people, and kind of put them on display for other students to consume and learn a little bit more about the chemistry department and stuff you can get involved in as a chemistry student. So since then, we've talked to other students about research, like undergraduate research. We've highlighted student opportunities, like working as an IA. And we've also just gotten to talk about like the past careers of some of the faculty here, like Dr. Weber. And so really enjoy those conversations. But you're the first principal investigator that we've had. And we've actually been wanting to talk to you since we started, but we've been kind of building it up, and we've been very excited to have this conversation. So a little background on yourself is just you're associate professor. You have a PhD in biomedical engineering, which is pretty special. You have a very large lab investigating nanoparticles and how they can be repurposed for therapies and diagnostics. Does that sound about right? And in addition to all that, you're demographically very special. You are a Hispanic woman, of course. And I was doing a little research, and according to the NSF in 2019, that's about 10% of all scientists and engineers. So that in itself is very fascinating, and we want to get into all those topics. But most importantly, very recently, we started, you started the PREM program, PREM 2.0. So we really want to highlight that opportunity for students who might be interested in getting into research, talk all about PREM, and get to know a little bit about yourself. But, first we just kind of wanted to talk a little bit about your background. So, I'm currently looking at graduate schools, and I saw that you got your bachelor's degree in chemical engineering, and then you work towards getting your master's and PhD in biomedical. So I don't know about your process, but I find it very convoluted, picking the right major and the right program at the right institution. And although I have learned a lot, I kind of would like to know what your thought process has been and why you decided to leave chemical engineering and pursue something slightly different, and then how that affected your current research interests in studying biomedical engineering.
All right, that's a great question. So the short answer is that I found the process very convoluted as well. And so I ended up changing several times. And whether that's a good thing or a bad thing, I don't know. It took me to where I am. As an undergraduate, I came from Colombia after high school. And so when I came to the United States, I was very, I guess, disoriented is the right word. I didn't really know what the process was. And so as an undergrad, I ended up in chemical engineering kind of through a stumble. I initially wanted to pursue physics because I thought that the science was super interesting. Then when I started my undergraduate classes, I found that my professor in physics, he did not seem very happy with his career. And that kind of translated to me, maybe physics was not the right field at that point. And instead, my chemistry professors were really awesome and excited, and maybe made me much more interested in chemistry. And one of those professors suggested chemical engineering. And I said, okay, why not? I like chemistry, I like math, let's do this. But I really didn't understand what a chemical engineer did. In Colombia, my parents were in the health industry, so I had no idea anything about production. We don't have those large scale, at least we don't visibly have those large scale plant, like chemical plants that we have here in the Texas area. Yeah. So I was not familiar with what a chemical engineer really did. I assumed that we would use chemistry and math, maybe to, like, I don't know, develop vaccines or something like that. And, you know, didn't really find out that that's not what most chemical engineers do until much later. So anyways, I studied chemical engineering. I liked studying it. I ended up working at DuPont in the La Porte area in Texas. I worked there as a co-op, and then right after I graduated, I worked a little bit there. And that was it's a large petrochemical company where they were synthesizing insecticides and herbicides. And so it was a great experience. You know, I got to work in those big chemical plants with the whole suit, anti-flammable suit, and climb incinerators, climb reactors, work with the operators. It was a really great experience, but it was not what I wanted to do for the rest of my life. So I went, you know, to explore grad school, and kind of with that idea of I wanted something that was more medically relevant, kind of like developing vaccines. So that's where I switched to biomedical engineering, where I could use the background that I already had, the math, the chemistry, and all of that, but toward a different application. And so that's how I ended up in biomedical engineering. You know, whether that was a bad or a good thing, you know, in the end, it ended up being good. In biomedical engineering, you have people that are from many different backgrounds. So it was not unusual for somebody to come from another field. There's a mixture of electrical engineers, chemical engineers that work together to develop new technologies. So it ended up working really well. The faculty that I ended up working with, their background was actually in chemical engineering as well. And so they were using the concepts of chemistry and math and engineering to develop new materials for biomedical purposes. And so that's where I ended up, and it has worked okay for me, I guess. But yeah, I mean, you know, looking back and now that I mentor students, you know, I think it's really important for students to learn what it is that your degree can take you toward, what kind of career opportunities are there for you, like really understand the major, get as much experience as you can while you are studying. So that's why I think, you know, undergraduate research is a huge thing, not only because you get to do things in the lab where you apply what you're learning, but you also get to learn the applications of your career. You get to learn, you get to meet you know, faculty and get to know them really well, and they can point out those career opportunities for you, those, you know, those trajectories, career trajectories to you. So I think that's really critical. And that was something that I missed as an undergrad. I didn't know that there was undergraduate research. I didn't get to know my faculty very well. I just kind of got my degree. And unfortunately, we still have many of our students that are just going through undergraduate in the same way, that are missing out on a lot of opportunities and a lot of information. So that's one of the things that I'm hoping to make a difference on. So I hope I answered your question.
Yeah, that was a great and a complete answer. I feel like in my search for graduate school programs, maybe a few months ago, everything was divided by like solid lines, and, you know, biochemistry programs are completely different from molecular biology programs, and so on and so forth. But I've come to realize that's obviously not the case. And like they said, like a biomedical engineering program is not necessarily completely. I mean, you probably take some of the same classes, I'd imagine. Even like biomedical PhD programs take the same classes as medical students sometimes, if depending on the institution. So I've really come to appreciate that, and knowing your background, that also really helps me kind of solidify my decisions moving forward too.
Right. And I would say, you know, going to grad school, what you really want to focus on is what kind of research are you passionate about, and then find what faculty are doing that kind of research. And then the major is not that important. Like in the same lab, you could have graduate students that are that are pursuing a degree in chemical engineering or biomedical engineering or biochemistry or chemistry, but they might be doing very similar research, right? And that's kind of the focus of your PhD. That research is the important thing that is going to open the doors as you move forward. So the degree itself, you might take different classes, but in the end, you end up kind of doing the same kind of work.
Yeah, at
maybe
the end of the day,
different focus, right? So making sure that you are finding a research opportunity that you're really passionate about, I think that's important.
So, after graduate school, did you have any industry experience? Could you did? Could you talk a little bit about that industry, that initial industry experience?
Sure. So I worked for about 3 years in a company in California called Innocence LLC. That was a short version of innovation in sensors. It was a small company. It actually is a small company. It's still ongoing. That initially focused on the development of optical sensors for the detection of gases like hydrogen or carbon monoxide, carbon dioxide. It is a company that is mostly funded through Small Business Innovation Research or SBIR grants from the federal government. And over time, as they have or PhD level scientists, the company has diversified somewhat in that, depending on the expertise of each employee, I guess, they would submit proposals to get funding from the government for the development of different technologies. So at the point where I joined the company, there were several projects on materials research. So not just sensors, but materials for like anti-fog coatings, materials for anti-flammable materials, I should say, coatings for preventing scratches, which would be kind of useful for goggles for the military, as well as sensors as well, electronic sensors and passive sensors as well. And so with my background in biomedical engineering, I was able to go to the company and start kind of a new line of technologies in the biomedical area. So I worked or I got funding for some nanoparticles, as you mentioned, that could be utilized as optical contrast agents for the detection of cancer. And then also had some funding for the development of a biosensor for the detection of cancer. And so again, the company was kind of had very broad focus depending on the expertise of the PhD level scientists. It was a great experience. Especially coming right after grad school, I was able to get a lot of experience and be able to climb up the ladder pretty fast because it was a small company. Having just graduated from grad school, at that point, I wasn't yet sure whether I could myself like come up with ideas for a new technology and pursue that. And within maybe 2-3 weeks of joining the company, I had to write a proposal, the first proposal. And I saw that, hey, I can do this. And I actually got good reviews from that one. It wasn't funded at first one, but I got really good reviews. And I was able to get funding after that for the biomedical technologies, and then ended up getting further funding for other technologies that were not in my immediate area of expertise, but that were materials related. That was also for, anti-flammable materials, and I already forgot the other one. Anyways, so I ended up learning a lot about the general materials area, and got to get a lot of confidence in myself, in my ability to be able to come up with new ideas and write them up and convince a panel that these were good ideas. And it was really exciting. And I got to work with really good people, both PhD level people as well as technicians and engineers. It was quite fun. And through that, I was able to see that, hey, I can come up with ideas. I can write grants. I can maybe go back to academia because I miss interacting with students. And so that's kind of what led me to come here. Kind of going back a little bit in terms of of working in a company, since it is a small company, one of the differences compared to like a large company is that you get to wear many hats. And so I was doing everything from being in the lab and getting dirty and doing things and fixing the centrifuge sometimes to cleaning the floor to writing the proposals and getting the money, right? Yeah. And you get to know a lot about how the company works and be able to work with everybody, like, you know, again, from the technicians to the president. And it's just a really great experience. It is also very time consuming. So it was probably not something that was sustainable for, especially if I consider having a family or something like that. It was probably not possible, at least for me, if I wanted to continue at the same pace as I was at that point. But it was a really great experience. What else can I tell you?
How long did you have your experience in your industry position?
So that one was for 3 years. 3 years.
So after 3 years, you kind of you said you wore many hats. You gained a lot of experience, and then you thought, you know, I miss students, I miss academia, and you said maybe this would be worth going back to.
Right.
What was that like? I feel like after 3 years of kind of being away from that area and then having to search for institutions that you would then go to, how was that?
It was challenging. I mean, the main thing is that it's not the traditional pathway for somebody to go to academia.
Right.
Typically, you go to academia, you go after graduate school, you would do at least one postdoctoral research position or fellowship, probably for a couple of years. And only then would you apply to an academic position. And typically you would have had many more papers because of the fact that you were a postdoctoral researcher during that time frame. And so I definitely was coming from a different background at that point. And so, you know, that was a challenge in itself. Having said that, because of the experience that I had and the fact that I had proposals that were funded and I, you know, had the evidence of that, and that's public information, that was probably something that worked in my favor. That, you know, it's kind of proven evidence that yes, I can get my own funding. Yes, I can run my own lab. I have done this already. And the other thing, you know, in terms of coming to Texas State, at that point, they were beginning the MSEC program, the Material Science, Engineering, and Commercialization program. And so they were specifically looking for somebody that, you know, wanted to apply to academia, but that had some industrial background. So that's something that definitely benefited me in terms of coming here. Yes. What else can I tell you? I mean, other than that, you know, I continue to have mentorship from my, it was actually my, how can I say, my postdoctoral advisor. So I did a short postdoc after grad school that was with Dr. Nicolas Pepas. And so he continued mentoring me. So we continued that relationship. And so he was able to help a little bit with that, you know, writing a letter of recommendation and providing suggestions during the application process. So that helped as well.
I did not mean, I can't believe I'm barely talking now in that whole podcast. I was just all the information is so interesting. I don't want to like break the flow of the question or the answer. Dr. Betancourt, I think it was like a year ago I like interviewed you for a class. So all this is like I'm remembering this information. Yeah. The one thing that you did mention though that I can kind of agree with is that there's a lot of opportunities in undergrad that a lot of undergrads aren't aware of until they either graduate or they're in graduate school,
Right.
which is, you know, way too late for that kind of stuff. So besides the undergrad research that is very valuable, you know, for experience, life, everything else, another thing I can think of is mentorship. Just looking for the right mentor that will give you time, in a way, take care of your, you know, brain, I guess, like intellectually, just kind of like guiding you in the right spot, providing good directions and all that good stuff. You mentioned your mentor that you briefly did a postdoc with, that then, you know, you kept that relationship going. So I guess I just wanted to ask, how important do you think keeping that type of mentorship and relationship going is, you know, for the future? I don't know if you're still in contact with this person.
Still in contact, yeah. I think it's absolutely critical. You know, having the right people that might have the right information or the right connections can really help, later on for job opportunities. Even while you're in school, they have information about scholarship opportunities, undergraduate research opportunities, and all of this information that you might not have. But continuing further, and after you graduate, you still need letters of recommendation for whatever positions you're going to. You still need pointers about career options. And associating with the right people can make a huge difference. So I still continue being mentored by Dr. Nicolas Pepes. He's at the University of Texas at Austin. And he continues sending me information. He actually organized it's like a seminar that is going to happen over a span of a few weeks. Starts on Monday, and he made sure to call me you need to sign up for this. Yeah, he does that. He's funny. But yeah, it's definitely very useful. So once you find a mentor that works for you, right, that it's a good match to you, definitely make sure to maintain that connection. And I would say, it might not be enough to have one mentor. Having different people that provide you with different perspectives, it's always useful, right? There's not one right way to do things, not one direction for your career. So having different people that give you different opinions, it's helpful. I suggest that everybody does that. Yeah.
I'm going to break the elephant in the room. You've actually been Edgar's mentor for some time.
A little bit.
Yeah, for a little time. And so I have my mentor, Dr. Ryan Peterson. He's my PI, my principal investigator for the lab that I do research in. And that's how I got that mentorship. But there's no there's not cut and dry way of getting a mentor. I think the ways I could think off the top of my head is you form a good relationship in a class, and then keep it going. Yeah. You obviously join a research lab, and hopefully that the PI is willing to be a good mentor for you in addition to your research development. And then there's also programs, like research programs, or I guess fellowship or scholarship type programs that'll pair you with mentors. And I think you two were through LSAMP.
Yeah, it's the HLSAMP program, and one of the requirements on that program is to have a mentor, and we can choose any mentor. The scholars can choose any mentor we want, and then we're just required to meet at least 3 times a semester, but it's kind of as you go during the semester. And actually, I'm glad you brought that point up, because when you Dr. Betancourt mentioned there's stuff that us undergrads don't get information wise, scholarships programs and all that. I definitely remember getting emails about oh, sure, in TNS, and there's this happening this way. And I remember one meeting we were talking about what does life look like after undergrad, and right after the meeting you sent me fellowships and places to apply for graduate school, and I was yeah, if I didn't have if we hadn't had that meeting, we didn't have this relationship, that's just, over my head, never to look at again. And then I think about, my peers, I just took an exam in inorganic chemistry, and, maybe the person sitting next to me does not have a person like Dr. Betancourt. And that in a way already puts me at an advantage because of the information that is there, but it's not, I guess, accessible to that person.
Right. Because the information is all there, but there's so much information that is hard to pick.
It's a whole world that we're trying to figure out. Yeah.
Right. Yeah. And like you mentioned, there's many ways to find a mentor. I find that working in research with somebody is probably the best way. Or at least myself as a mentor, those are the students that I interact with the most. And so those are the ones that I'm always sending all of these pieces of information to. I also have students in classes that come to office hours and that kind of thing, but it's really those that are in research that are the most, present in my head about remembering about these opportunities. So I definitely suggest that, but yeah, there's many different ways to get mentorship. And as you mentioned, there are several programs that foster that, starting that relationship. And I'll just mention as a quick note, I mean, Edgar already had a ton of information, so I found it hard to find any information that he didn't know already. It didn't feel like he didn't need mentorship because he's doing all the right things that he needs to be doing. So
I appreciate that. Well, either way, I still find it very, very
this one thing
beneficial.
useful, so that's good.
No, but it was still really, really good. I think now the reoccurring point of research, and research is important, and finding research and a research mentor. Maybe it's time to talk about PREM and what PREM is, and
Right.
why you're here. We have the director of PREM. So, Dr. Betancourt, what is PREM?
So PREM, it's a 6-year grant that's sponsored by the National Science Foundation. PREM stands for the Partnership for Research and Education in Materials. And our PREM grant is titled the Center for Intelligent Materials Assembly, which, if you abbreviate it, is the CIMA, so the PREM CIMA grant. It is a grant that has the objective of increasing opportunities for participation of underrepresented minorities in material science specifically, but in STEM in general. And the way that it does that is by kind of fostering the partnership between a minority serving institution like the Texas State, together with a large research center, which in this case, we are partnering with the University of Texas at Austin and their Center for Dynamic and Control of Materials, or CDCM. They are what's known as a MRSIC. There's a lot of abbreviation, but they are a MRSIC, which is a Materials Research, Science, and Engineering Center. So in general, for students, what this means is that we have a large grant for 6 years that is going to provide funding for new research opportunities for the faculty. And as such, that's going to bring in opportunities for many students to be engaged in that research, and not just research, but also a lot of educational opportunities. So we have actually already kind of hired our inaugural class of students that are going to be in the program, but we will definitely be looking for students for all the future years. And what students will do in this program, it's what I should say, like the way that we are engaging students is to kind of through a 2 or 3 step process. The first process is, we call it the PREM Associates, which is where students that are not yet in research, but who are kind of interested in finding out what this research thing is, are going to be engaged in these meetings that occur every 2 weeks. And during those meetings, they'll get to learn about, what PREM is, what opportunities there are for the students to learn and be engaged in. There will be training on all kinds of things, from how do you apply to scholarships, how do you apply for research experience for undergraduates or REU programs, which are basically summer research opportunities. How do you apply to grad school? We'll have career panels so that you get to learn, what kind of careers can you have with a degree in chemistry or physics or engineering. Also, we'll have training on like inclusion and diversity topics to make sure that we're creating a cohort of students and faculty that are very inclusive of all of our communities. And of course, we'll also have student presentations for the students that are conducting research and all of that. And so as a PREM associate, you will be getting a lot of this information that we were talking about, that's so useful for you to know while you are an undergraduate. And then the second cohort of students are the PREM researchers. And so those are students, both undergraduate and graduate, who have already engaged with a faculty member and joined the lab and are doing research. And those students are going to be receiving paid, a stipend for their work, and there'll be funding available for the research supplies and for travel to conferences and all of that. And those students will be engaged in projects that are in collaboration with the University of Texas at Austin. And so not only do they get mentorship from the Texas State faculty, but they also get opportunities to meet with the faculty over there, meet with the students, maybe go to UT Austin and use their facilities and, go to their group meetings and kind of learn how things happen at another institution. And for undergraduate students, they'll also have the opportunity to do summer research at the University of Texas. What else can I tell you? And then, our third cohort will be the students that are graduating from the program. So when the students graduate, our hope is that through all of the experience that they have gone through, that they will go to graduate school or higher degrees, or at the very least to the material science field, in the workforce. And that then they'll act as mentors for our students here. So we'll have a lot of industrial contacts and or academic contacts within the 6 years. So that's kind of the overall summary of the grant. And for students to get engaged, we have our PREM website, which I should have looked up beforehand. And
we'll put it in the description.
Put it on there. Sounds good. Sounds good. So students can get engaged by filling out the how to get involved. And then from there, what happens is that I will email them and tell them, when the next meeting is and what kind of information we can provide them, all of that. But our hope is to have about 20 undergraduate students and about 10 graduate students involved as researchers every year, and many more PREM associates from all the STEM fields in the college, in the College of Science and Engineering here. So, I should also mention that the grant involves 9 faculty members from Texas State. That's 6 faculty from chemistry and biochemistry, 3 faculty from physics. And so there's quite a variety of research opportunities available, anything from, in my case, biomedical technologies, to my colleagues' work on materials for water purification, materials for electronics, or nanoelectronics, I should say, semiconductors, photonics, all kinds of things, including synthetic chemistry as well. So there's all kinds of research available for students to get engaged in, all of which have applications in daily lives and in the future of materials. So it's quite interesting.
I think this is great. I mean, this is genuinely one of those things that I hear and I wish we had when I was a freshman. Yep. That makes sense. I'm sure Nick was thinking the same thing. That it's just kind of one of those things that, like, wow, this is so useful. Where was this when I was a freshman? Yeah. But it's great that it's here now, because as we were talking early on in the podcast, these are things that are very much needed, for your undergrad experience, so that, whatever you do after undergrad, you're well equipped with information, with skills, and, all that stuff. I'm lucky to be a PREM scholar. I'm working with Dr. Martin this semester. And one of the things that I find very beneficial about this program is the collaboration with UT, University of Texas at Austin. I think that's, 1, great, and 2, very eye-opening, especially for students who have not done research outside of Texas State. I've also been able to do 2 internships with Eli Lilly over the past 2 summers, and the research that goes on there in comparison that goes on here is, similar with some points, but very different. And the way that they do things and they carry things is very different. And so it's a really good experience to be able to see the way that another institution works, and, oh, they do this because of this. And then you yourself start making connections and then relationships with the people at UT that then prepare you for that life after undergrad. So I think that's great. I'm really happy that this is here at Texas State. I'm really happy that it's here for some time too. You said 6 years.
Right. It'll be for 6 years at least. Hopefully we can renew it again. Yeah.
This is a huge grant. It's a huge grant. I mean, this entire program, it's pretty crazy to even think about. Did you apply for this grant yourself as the director? I assume you did.
Well, I was the principal investigator, but it is group effort. A lot of or a few of the faculty members participated in PREM 1.0. You mentioned that this is 2.0, so we have a PREM, And so, you know, we had already worked together and we knew kind of what things needed to happen in this grant. And so a lot of it was already kind of established, but definitely we had to kind of renew the ideas and get new blood into the program. And so we you know, got new faculty from chemistry and from physics, kind of renewed the ideas and all of that. And yeah, so it is group effort for sure. And the implementation of it, yeah, the implementation of it is also group effort in that we, you know, each of the students are going to be working with different faculty, and those faculty members need to act as mentors as well, as we've already mentioned. And there's a lot of coordination happening between all of us, but we cannot be successful if we are not all successful, right? We all need to be proactive in student engagement. We all need to be successful in our research enterprises and publish and have our students present and be co-authors. We need to make sure that our students are graduating and going to great places. So it requires the whole village. Everything has to work well. Otherwise we will not be successful. So I guess that would be my answer. But there was something else that you guys mentioned that I wanted to touch on. Oh yeah, it was what Edgar mentioned in terms of getting experience somewhere else. I think I agree in that that's a critical piece that we'll really need to take advantage of, because, you know, you guys here are getting one type of experience, and at Texas State, we have the luxury of still having that kind of one-on-one connection between faculty and students. And that's not something that necessarily will happen at an R1 institution. And so one of my hopes is that students do get the opportunity to be engaged in how things are happening at the other institutions, so that they see that, you know, things might not be like that, right? You might need to be a lot more independent for you to be successful at an R1 institution. You might need to already know how to do research yourself to be successful over there. Because in the past, I have seen students that do really well here when they are being closely mentored, but then they go somewhere else and they might not do so well because they need that, you know, that connection, and that might not be something that happens there. So I think exposing the students to that as well will be important.
To clarify, R1 is a research level 1 institution, right?
Correct.
And Texas State is a research level 2.
I believe so. It's I know it's an emerging research emerging research institution. I don't know if these are two.
I know that's the end goal for Texas State. That's where we would like to go eventually. And I think one of the best ways that Texas State is doing that is creating opportunities like PREM to get underclassmen students involved into research earlier. So freshmen and sophomores. If you can get a freshman or a sophomore into a research lab, that is huge for their undergraduate career development, their ability to be successful in their courses, their ability to get scholarships, funding for research. It has like a compounding effect, so that by the time you're a senior, you're more than prepared for graduate school. I started exactly like a year ago in a research lab. That's my junior year. And that's one of the things I wish I did, you know, and a lot of people say this, I wish I started earlier. And you know, sometimes that's just how it plays out. And nonetheless, I think getting into that research experience earlier, if you're interested and ready for something like that, which is something I want to ask you about, is really valuable. But do you have any advice for a freshman or sophomore who might be interested in becoming like a PREM associate, for example, might think, oh, that's kind of cool, but they don't particularly think they are, you know, quote unquote ready or know where to start? What would you advise to them?
That's kind of the intention of the PREM associates cohort, that they're not necessarily expected to work in research immediately, but instead they will be participating in these meetings every 2 weeks and gathering that information, right? They're going to start hearing about what is undergraduate research, how do I get involved, what kind of research is happening in the labs, in the PREM, how are students actually participating in that research, who is doing it. And so they'll get get that information, right? And then through that process, they'll start kind of thinking themselves, how do I see myself in that role, and when should I do that, and which professor should I approach, right? Depending on all of this, everything that they're hearing through those meetings. And so our hope is that within a year, perhaps they are ready, if not beforehand. Now, in terms of being ready, what does that mean? I mean, that's going to be something different for every student, right? You don't need to have prior knowledge about the research, right? You don't have to, we expect that you don't come trained already on the instrumentation or the techniques, or the research itself. We expect that you have some vague knowledge about what the research is that's happening in the lab. Like, I know that Professor Betancourt works in nanomedicines or biomaterials, and that sounds really cool, right? But we don't expect that you come trained already. You will be trained on all of that. And so you don't have to wait until your sophomore, junior, or senior year to join. And in fact, joining when you're a senior is probably too late. You won't be able to get a significant amount of work done. So I would encourage students to join as early as they can, while still making sure that the student is doing okay in their academics, right? The first semester might be too overwhelming. You want to make sure that you are planted at Texas State, that you know how the university works, you know how to be successful in your classes, and then kind of take the plunge and join a research lab at that point. You want to make sure that you have at least 5 to 10 hours available during the semester to work on the research, or that you can put a whole summer toward that role. But other than that, what we're looking for is mostly enthusiasm, some level of interest toward the research, or passion toward the research, or toward the topic of the research, I should say. And then everything else comes through hands-on work, right? Learning the techniques, learning the background behind the work, learning how to analyze the data, how to troubleshoot. All of that comes, while you're doing it. Mm-hmm. I hope that answers the question.
I think it's a really good answer that not a lot of people hear, and hopefully that changes. But that encompasses exactly what I think people should consider when getting into research. I kind of want to come back full circle a little bit. We're going to be wrapping up soon, but this might not come as a surprise to you, but you're the first Colombian scientist I've ever met.
Right.
Yeah. As a Colombian myself, when I took your Gen Chem 2 class, 2019, I found that very motivating or encouraging to see that you were Colombian, you were my professor, and I did not really see that, and I think that's something that correct me if I'm wrong, but I don't think so. Encourage you to look at Texas State, a Hispanic serving institution. Also an institution that has a really high percentage of women undergraduate students as well. How did you see yourself kind of fitting into Texas State when you first got here, and how do you use your culture as a Colombian in your career? The good, the bad, the everyday experiences. I know it's a loaded question.
Right, it's a loaded question. I mean, I can tell you that when I chose to come to Texas State, that was one of the main reasons why I decided to apply and then to come to Texas State. At that point, the percent Hispanics at the university was much lower than it is now, but it was still significantly higher than at other institutions in Texas. And so that was one of the areas that really called my attention because I wanted to make an impact. I mentioned that before I came here, I was in industry, and in the company, I was the only Hispanic other than all of the janitors. And that's not something that is uncommon in every industry that I've been, and even in graduate school at the University of Texas. There was me, and then there was one African-American graduate student for the whole 5 years that I was there. So we were the minorities. That's it. And so that's something that I really wanted to make an impact on. Make sure that our Hispanic students are aware of the opportunities that are out there to them. Make sure that they know about these career options that are really, they're really good. We have high pay, we have good quality of life, we have flexibility. That's something that many of the people in our culture don't have right now in the United States. And so I wanted to make an impact on that for sure. Now coming here to Texas State, I actually did not know about the percent faculty at Texas State that would be minorities or anything like that. It is higher than at other institutions here, but it's still low. And that's not something that's Texas State's fault necessarily. Like if you look at the demographics of students at the undergraduate level versus graduate level, you can see how they start diminishing and diminishing. So the pool of people that are available to pursue these careers, it's quite small. And in material science, the numbers are just awful. Both for Hispanics, probably, I don't know, maybe 5% of Hispanic, 5% of the people getting PhD degrees might be of Hispanic heritage. And so again, the pool is very small when you look at faculty. Now at the university, I think I've seen a lot of support within my department. My department has been absolutely great. My chair and the people that I work with, they are nothing but supportive, and they don't treat me any different than anybody else. There's no extra benefits, but I do love working with them because of the way that I see them mentoring their students who are Hispanic. So even though I'm the only one Hispanic in the department in terms of faculty, but I see that the faculty members that I work with are very supportive of the students, and they also have that same goal that I have in terms of providing the opportunities to all of our underrepresented minorities. So I love that about the department. And the university, there's quite a few groups and organizations that are trying to encourage more participation and changes at the university level. There's the Hispanic Policy Network that involves faculty and staff and even students that discusses a lot of policies and reaches out to the president when things are happening or need to happen in that area. So there's a lot of things in the works, but I think we really need to focus on our undergraduate level and even beforehand to try to increase the number of people that actually reach those places and through that make a change in our society.
I don't know if we did this on purpose, but I think this month is Hispanic Heritage Month, and we're 3 Hispanics.
Yep, there you go.
I just realized that.
That's
it
right.
It was completely on purpose. We thought this out. This was yes.
Okay, of course it was.
I want to second what you said about the faculty in the department being very supportive about undergraduate minorities being successful and helping their growth in their careers. I completely agree with all that. I mean, just look at the infrastructure in the department, the research programs that are available, the scholarships from the College of Science and Engineering that are specific to underrepresented minorities. That's one of the high priority goals of the NSF, the National Science Foundation, is to increase participation of underrepresented minorities. So to that, I'd say to any underrepresented group, which is becoming a broader term every day, it seems. Yeah. That if you are passionate and interested in science, there is a lot of support, especially at Texas State. That's why I came to Texas State, is because it was a Hispanic serving institution. I felt very welcomed here. So I want to thank you personally for being one of those role models and people who support us, but also everyone else in the department who isn't in this Zoom meeting.
If I may say one more thing, because now I remember that at the beginning you started with the preface of being from Colombia. And that's something that has definitely helped me in terms of the education that I received in Colombia. I feel like it was very different than what I would have gotten here in high school, for example. I don't know, but I loved school. I don't know about you guys, but I loved school. they kind of instilled a passion for learning and for loving the process of learning. And so I was like so surprised that they would pay me to go to grad school, like to pay me to study. That was like shocking to me. I was like, why not? Why doesn't everybody do this? And and we're also very hard workers and very creative. And we say like echados pa'lante, like we lean forward, right? Lean forward and go for any opportunity. So that's probably something that has helped me out. At the same time, being from elsewhere, I'm very naive about many things, and so I just go for things and hope that it works out okay, and have had good people along the way to guide me and help me along. So I think that's made a difference in my life.
I've definitely had this conversation before with a lot of people where I really think that Hispanic people have this drive in them that I don't think another group has. And I think it's just like the common struggle that like, we have, growing up, that not a lot of groups of people have. I think that's like what really drives Hispanic people forward. And I think that's very special. And you can see it on like any Hispanic person that you see, that it's like, they're really trying their hardest. They're like, I don't know how, working like so many hours, and it's like, they seem like they're not tired because they still go home and like with their family and all this stuff. But it's just like drive that they have within them, like this fire to just keep working. And it's just échale ganas, just keep going. I can definitely see that with my parents, within myself, within my friends, within the faculty that are Hispanic. And I think that's really, really special for like Hispanic people to know that exists, and for also that is one thing that we are known for and that we can do,
and that we need to make sure that we don't lose.
Yeah.
Yes.
Future generations too. So yep. And that shows in the fact that you guys are the ones who are doing this, who are coming up with these ideas and trying to distribute this information to other students, right?
Wow, full circle. This really went full circle.
We've covered everything that I really wanted to talk about, and everything that we really wanted to focus on in your story. We just wanted to say thank you so much for doing this. Hopefully other faculty kind of like follow after you and decide to join us as well as students and others. But we really appreciate your time. I know you're a very busy person, and rightfully so. You do a lot of great things. So thank you so much for your time. Thank you, everybody.
Thank you, Nicholas, and thank you, Edgar. Thanks for giving me the opportunity.
Bye, everybody.
Bye. Take care.